Hey, hello folks. Welcome back to the second workshop of Future Stack Gen AI Hackathon. So in this hackathon, in this webinar, we'll be going over Docker and we'll try to see everything which Ajit has for us for this workshop, right? Just a quick plugin for new folks who have recently joined. So we are hosting a 1 week hackathon named Future Stack Gen AI Hackathon, wherein some Cerebras is our sponsor and co-sponsored by Meta and Docker as well. So this is a great chance for you to win $15,000, $5,000 each for every winner out there, right? All the information about the hackathon can be found in the description below. So if you want to check about the rules, resources, or anything about the hackathon, check out the description. Every resource which is which can be utilized in order to help with this workshop is also can also be found in the description below, right? If you have yet not joined Cerebras Discord, make sure you do it because all the hackathon reminders and updates are being shared over there. So make sure you join the Cerebras Discord, and that again can be found in the hackathon page by VMakers, right? This webinar will be more, let's say, hands-on, and it will be detailed, and it will be a long webinar. So I'll not take much of your time. I'll just jump straight to the speakers. Ajit, would you like to give yourself a quick introduction?
Yeah, thank you. Thank you, everyone. It's glad to see you all. So yeah, my name is Ajit Singh Rana. I'm part of the developer success team, working as a developer advocate, and I have with me Oleg. Can you introduce yourself?
Hi, everyone. My name is Oleg, and I'm from Estonia, and I also work on the Docker's DevRel team. And we are super happy to see all of you here. And we're going to go through a bunch of things today. Building agents, we're going to connect things. We're gonna talk about building agents, and I'm super excited for that, frankly, myself.
Yep. Thank you for joining, Ajit and Oleg. I'll leave you folks to the stage and to share about everything about the webinar. Yep.
Thank you, Ayush.
Yep. Thank you.
Okay, so let's get started. The first thing is what we are going to build today. So today in our workshop, it will go till I would say for around 2 hours. What we are going to show you is the power of Docker, Google Agent Development Kit, and Cerebras to build a secure AI coding agent. Now, this is a layered architecture altogether, where we will move towards, right from your user interface back to the intelligent orchestrator, using an agents, using a gateway for securing your overall MCP servers, and then back to the MCP servers, how they are, how these tools are being detected. So this is a kind of a layered architecture. And as you know, right, you can deploy the overall architecture itself using an Agentic Compose. So that's the power of Agentic Compose. So in this session, we will talk about each of these components, how they work together. We'll also look at the Cerebras agent. So we will look at both as running the local models as well as the cloud APIs, how you can use those models which are running on the cloud itself. And throughout this session, it will be more very interactive. We will quickly see how to set up our infrastructure, and slowly we will see how these components stitch together to build a kind of an agentic AI application. Okay, so just to remind you that for this hackathon challenge, we have number of sponsors. We have Docker, Cerebras, and Meta. There is a kind of an expectation from each of these parties, especially from the Docker side. We are looking at the most creative usage of Docker MCP gateway. Now, this is basically a tool which has been introduced. This is an open source tool which helps you to manage the life cycle of your MCP servers. And again, there is an expectation from the other parties too. So ensure that you visit this particular link to understand all the rules and regulations. And these also holds, there are couple of resources and links which you can go through it. Okay, so as it is 2 hours workshop, so what I have done here, we have tried to split it into multiple labs. Lab 1 will be more like a prerequisite and setup. We'll start from basic, how to install Docker Desktop, enable model runner. Again, model runner helps you to run models locally on your Docker desktop or on any of the Linux system. We'll also see how to configure MCP toolkit. And to make it quite easy, we have something called as a Labspace, which we are going to set up locally. So as you see, right, there are certain playgrounds which are hosted on the cloud, but this is one playground which you can deploy it locally on your machine. Now, this is what we are going to take around 15 to 20 minutes deploying all of this thing. Then we will move to the lab 2, where I am going to talk about Agentic AI services, microservices. And in this, I will give you the basic fundamental of what are the components which we are stitching together. Now, if you look at the Agentic AI application, it holds LLM, MCP, MCP tools, MCP gateway, agent application, right? So we'll go through each one of them. In this section, I will cover the model runner as well as a toolkit and MCP gateway. And finally, we'll also look at how to set up the AI coding agent. We'll understand the high-level architecture, project repository, component breakdown. So we'll get into each of these files and how they stitch together. And that would probably take around 30 to 40 minutes. So for the next, I would say 100 minutes, we are going to deep dive into each of this section. And throughout it, if you find that there are some kind of a difficulties understanding it, definitely Oleg is here to help you out with any of the chat queries. Put it in the chat window over the YouTube. There are descriptions, there are resources, and we will be here to help you out. Now, during this course of hackathon, there are a couple of things which you will learn. The first thing is you will learn how to deploy a multi-agent system using Agentic Compose. You will know how to orchestrate the multiple AI agent for specialized tasks. We'll also see how to integrate Cerebras AI into your agentic app and explore MCP gateway and its capabilities. So there is a lot of things which you can explore, and these are the fundamentals. You need to know this to build a kind of the agentic AI application. So let's get started. First, we'll start with the prerequisite and setup. The first thing is you need to have a Docker desktop installed on your machine. You can go to docker.com, and based on your infrastructure, say if you are using Linux, you can install Docker desktop for Linux. If you are on Windows, you have a various variants of AMD as well as ARM based. And then if you are on the Mac, again, we have separate bits for Apple Silicon as well as the Intel chip, right? So feel free to get into this particular link. You can go to the Google, search for it, and download and install on your machine. As I have already installed it in order to save the time, so ensuring that you get started, and also you will get a time when we will talk about more theoretical about the agentic AI and how it moved from we are moving from the chatbot to the multi-agent system. As a prerequisite too, you have to enable Docker model runner. Now, if you want to run model locally, so Docker has introduced a kind of a feature which it is rightly integrated into Docker desktop. When you install Docker desktop, you will see that this is one of the feature which is available. You just have to enable it. Now, how to do that? So when you have a Docker desktop installed, you can go to the settings, AI, and enable model runner. Now, to quickly show you how it works, I am sharing my Docker desktop window here. If you go to the settings here, under the AI, you will see an option called as Docker model runner. Now, let me tell you something about the model runner here. So this is a kind of a feature which has been introduced and allows you to run model locally. Now, where are these models available? They might be available on the Docker Hub, or it could be in the Hugging Face. Now, if you are downloading from the Hugging Face, right, we use the same command Docker model pull and give the link of the Hugging Face, and there you can download all those models. If you want to use in the Docker Hub, the command is going to be the remain this, it is the same command. So in my one of the slide, I will show you how to go ahead and download it. But at this point of time, you just have to go ahead and enable Docker model runner. If you want to use a host side TCP support, right? So for our demo, you need to go ahead and enable it. So by default, it uses 12434, but it's your choice. You can go ahead and choose your own port. Now, coming back to the slides here, once you have enabled it, the next step would be more like, you have to pull this model, as I said, right? So for this workshop, we are going to use 4 different models here. 2 of them, which are listed on the top, are from Hugging Face, which means that today I can pull the model directly from the Hugging Face in the form of a GGUF format, and I can run it locally. If you want to pull it from Docker Hub, so you just have to specify AI / and the model name, and with the right quantization, right? So going back to my screen here, if I open up my dashboard, get into the models, and if I click on Docker Hub, I can see a couple of these models here, okay, directly on my Docker desktop machine. I can always search for Llama, and it should display me all those different types of models, right? Llama 3.1, 3.2, 3.3. If I want to pick up, say, Quen model, I can just search for it, and you can see all these models can be downloaded. Now, all of these models comes with their own specific, parameters. Few of them are like a large language model. Few of them are like a small language model. But for our workshop, what we are going to do, we are going to pick up these specific models here. Now, let me spend some time around what are these models and why we are picking up this model. Now, choosing an AI model is important, right? There are close to around 2 million models on Hugging Face, right? And you might ask, like, why should I pick this model altogether, right? Why we picked up this particular model for our use case? Now, the first thing you need to understand is, as I categorize all these models in terms of large language models, small and medium, right? Each of these models comes with their own billion parameters, right? These are very similar to how you have a simple calculator as well as you have a scientific calculator, right? So Llama 3 has around 1 billion parameter. It is perfect for your coordinator agents. Think of it as like a project manager. It does routing really well. It's extremely fast. It does a simple task like routing, basic classification and coordination. At the same time, you have a Mistral, which is like a balanced workforce, because it is very good as a worker agent, right? So, but it has its own 7 billion parameter, which it consume around 3.4 to 4 gig size. Now, for our AI coding, I'm going to pick up 2 of the models, right? I don't know whether you might have heard it for the first time, but these are the models which comes with their own MCP tools capability, as well as they are very good in coordinating, right? And that is the reason why I picked up Jan Nano and Lucy, again, downloading it from the Hugging Face. So I have few of the slides where I'm going to get into Model Runner, how it works, why we are picking up this. So we'll discuss about it later point of time. Now, the prerequisite for we need Docker MCP toolkit. The reason being, for any of the agentic AI application, my agent has to talk to the MCP, right? So we need some kind of an MCP server. Now, for this workshop, we are going to pick up Context 7 and Node.js Sandbox MCP server. Now, both of these MCP servers are important in the sense that when you pick up Context 7, it gives you a real-time access to your documentation, right? And Node.js Sandbox MCP server runs a Node.js instance on a sandbox environment on a Docker container. Now, when we are trying to communicate and we are trying to set up these kind of, when we are setting up this agentic application, we will use Node.js Sandbox to spin up and test and run the test cases. Okay, so that is the reason. And how to do that? So going back to my system here, going to the dashboard, if you click on MCP toolkit on the Docker desktop, we have catalog of around more than 220 plus MCP server. I can search for Node.js, right? And you can see here Node.js Sandbox. If I click on it, you will see that it has 7 different tools. Okay, and these tools, what it does, it basically runs the instance of Node.js altogether. Now, if you look at the configuration, we don't need any API keys or any kind of a configuration. So this looks good. The second one would be the second one which I have enabled for this would be Context 7, right? So I can always go ahead and search for Context 7. Now, as I said, right, Context 7, what it does, it provides you with the up-to-date code documentation for LLM and AI code editors. It doesn't need any kind of a configuration, and it provides you with the two tools: get the library, resolve the library, right? So these are very basic, I would say, the MCP server configuration which you have. Otherwise, if you pick up other MCP server like GitHub, you need to provide a personal access token. So each of these MCP server which are listed has their own configuration. But in order to save time, so we picked up two of them for our use case. Now this looks good. Now going back to my slides. So once these are enabled, we need to set up a DevDuck Labspace. Now what we are going to do here. Now, as you know, like there are multiple playgrounds which allows you to create the instances over the cloud. Think of it as like Eximius or killer.sh or the killer coda which we used to have, right? Now the problem with these lab spaces are these kind of a playground are they are hosted on the third party, right? So what we thought that why can't we have our own kind of a lab space which we can set up locally? So this is a fully packaged playground environment for our labs, workshop, and training. You can run it locally. This is an open source project. You can go to docker sample / labspace infra to see the code, and you can spin it up on your local machine. So why we are setting it up? The first thing is we are going to follow a tutorial where you can see the split window where we are going to run a VS Code right on our browser and try out all those commands, right? So for this, what you need to do is there are certain steps. The first one is you need to enable Docker extension. And then we will try to do some kind of a configuration. Once it is enabled, we will install a Labspace extension and then add a specific lab space which I have prepared for this particular AI coding workshop. So for this, I would suggest you to go ahead and run docker extension install docker samples / labspace devduck. So let me show you how it look like. So if I go back to my machine here, go to the settings, and you will see an extension. Now, what is extension here? Extension helps you to add third-party capability or tools rightly into your Docker desktop, which means I say if I want to build my own observability stack, I can do it using an extension. Right now, there are more than 150 plus extension, right? Grafana, and there we have OpenShift, and all of these extensions are available today. So what you need to do is ensure that you only have one option which is available, because right now we haven't put this extension into the Docker marketplace. That is the reason why I'm deselecting it. So once you enable this extension, all you need to do is go to the terminal and run a command called as docker install extension, which I can show you here. So docker extension install docker samples labspace devduck. Okay. So by the way, I have prepared all these steps on one of the portal, which I am going to just link you so that you can follow that. But for now, you just need to go ahead and install an extension by the name docker samples / labspace devduck. Okay. Now, once you do that, you will get a kind of this kind of a UI. Okay. And where you can add this lab space here. So what I can do here, I can name it as say DevDucks and under the OCI, because now what I'm going to do is I can bring up this lab space using a Docker Compose file. So what I need to do is docker samples labspace -devduck. So all you need to do is just go ahead, add it, right? And it is going to basically pull a Docker Compose file and run multiple services. At the end of the day, it is nothing but a Docker Compose services which comes up. So to save the time, what I have done, I have already launched it. So let me go ahead and relaunch this, and you can see all these services are coming up. And once it comes up, I should be able to go back to my system and access it at localhost 3030. So you can see here, I have a complete playground environment running on my web browser. And what do you get with it? It is basically a split view. On the left-hand side, you have all the instructions which you can follow for this lab. And on the right-hand side, I can run a VS Code directly on top of my machine. So you can see here that I have few of the commands which I have already run. So you can always, you have a flexibility to, minimize and maximize all those instances. And what I have done here is more like, in order to save my time, I can have the whole project, lined up here. Okay. So let's look at this instruction first and try to see. We have set off the steps from 1 to 9, which you can go through it. And by the way, if you want to access, if you don't want to access to the Labspace and access on the portal, so if you go to docker devduck.vercel.app, you can see all the instruction here. Say if it is delaying for you, or you are not able to bring up your system, it is quite slow, I would suggest you to go through this link, which is docker devduck.vercel.app. So let me show you this particular link. This is how it look like, docker devduck.vercel.app, and you can access your complete workshop here. Okay, so as you see here, my Labspace is up and running. I can access all these menu here. So first, what we are going to do is, I have tried to include all the details here under multi-agent workshop. If you click on prerequisite, you will see what are the prerequisites which you require here. You will find out kind of the instruction for download this AI model. So all you need to do is just click on this link, and it should be able to give you the result. So think of it as, if I want to run this, I can, okay, let me see if I opened it on the new browser window, but you should be able to run this command. So let me go back to my system and open a new instance for you guys. Let me go here, and what I'm going to do is more like, I will open the same instances here. Okay, so in one way, what you're going to do here is, you should be able to click on the link, because since I've already installed that instances, that's why it says like, okay, you can't go ahead and run those same command here. But now what we are going to start here is more like the step by step. The first one is DevDuck. So what I have tried to do is, you can go through this link, try to understand how it works, and then what are the real world application. So one by one, we will go through each one of them later point of time. Okay, now let's come back to the slide and try to see what is in this particular part. So before we jump into an application directly and clone and start with the kind of an coding agent, I want you to understand what we are trying to achieve here, right? So let's talk about Agentic AI as microservices first, and try to understand why we are building this kind of project. What are the different components, right? Okay, now if you look at the way how the AI landscape is moving, right? We are moving from the chatbot, which is powered by the single LLM, right on to the multi-agent system, right? And again, this is more like moving from a reactive system directly to the collaborative networks, right? So think of it as like, when you go to the Claude or Chat GPT and ask something, right? It is at one point of time, it is just using one model. You are using one model, which means that you have a dependency on this model. And each of these models are nothing but a snapshot of a data, right? So there are two parameters which we are seeing here. One is complexity, two dimensions. One is complexity, the other one is autonomy. And you can see here that we are moving from a single LLM to the multi-LLM system. Now, if I try to compare it, the generative AI versus the agentic AI, you will see that you go to any of the AI assistant, provide a prompt, it uses the LLM and it generates the text. But now what has happened that now we are looking at the use case where, say, if you want to use a multi-LLM architecture, because if you look at one LLM can't do all the stuff, right? One LLM might be good. Say if you look at the Claude is very good in reasoning, in giving you a complete, building a kind of a software for you. But at the same time, it has to generate the images, like you have to depend on other LLMs, right, which are expert on that. So every LLM comes with their own expertise. In terms of agentic AI, what we have seen is, rather than just generating a text, now we are talking about the problem statement. If generative AI is more like a content creator, agentic AI is more like a problem solving machine. Okay, so it comes with a goal, it plans for this goal, it acts, it reflects, it learns, right, from the particular task, and then it tries to improve itself. And again, we have a memory in place, we have a system integration, because how it integrate with the different MCP tools, that comes into the picture, right? So a typical agentic AI application looks something like this. You start, say, if you add a prompt saying like, show me all the GitHub issues and create a Notion task list, right? So this is a user input which goes to the agent application, which might have a memory and the feedback loop. Then the LLM come into the picture. And for LLM to understand the context, it has to get access to the tools, right? And that is where your MCP tools come into the picture. And these MCP tools could be, like in our case, in this particular example, it might use the GitHub MCP tool. In the same way, it might use the Notion, right? So you need to add some kind of a configuration. So just like you saw in Docker MCP toolkit, we have a catalog, we have a client, we have a server. Those components, when they come with each other and give context to the LLM, that is where your agentic AI come into the picture, right? And that is a trend which we are seeing right now. And we are trying to, whatever we are trying to build as a coding, AI coding agent is something which we are building, right? Now, if you look at each of these components, right, the agent application, we need to have an intelligent orchestrator. In terms of memory, you need to understand the context. You need to, an LLM is doing more like a reasoning part, right? Feedback loop is more like a self-correction. So one time you might have seen, when you connect your Claude or any of the LLM to the tools, then if it gives you, if it hallucinates, right? So there are chances that once it has access to the tools, it tries to auto correct itself, right? And then at the end of the day, we have an MCP tool which basically does all those, execution part. Now, the challenges in building this agentic AI application is like a threefold. The first one is learning curve, right? And if you can see here that 76% of the dev don't consider themselves proficient in Gen AI itself. So most of the time it happens that there are so many pieces, moving pieces in the Gen AI, right from you add the prompt till the time when you get a response. There are observability stack into it. There is a brain of the whole Gen AI application, which is an LLM. You have multiple rack system come into the picture. So these terms always, there is something new which is coming up every new week, right? So there is a learning curve, there is a tool discovery. Now, if you ask me how many MCP servers right now, there are more than 8,000 plus MCP servers. And these MCP servers are either built on Python or Node.js. And if you have a multiple instance of this MCP server to be run on your local machine, there will be a dependency hell. There will be the problems which we faced when Docker was not there, right? Again, running multiple instance of Python application, multiple instance of Node application. And that is the reason why you see the project like NVM has more than 80,000 plus GitHub stars. The reason being you are having a multiple version of Node.js running it. And these programming languages are powering those MCP server when you run it as an undockerized environment. And the third one is, every time you talk about these tools, every time you talk about the Gen AI application, the first topic which comes to the mind is, okay, how secure it is. Because now you have a dependency on the cloud APIs, right? And your data is going external outside your infrastructure, right? So you are always, worried about who is going to consume it, what kind of an API is being used. So, uh, so what Docker is solving the problem here is, it is providing you with the trusted content, right? It is providing with the simplicity, security, right? We have tools like MCP gateway, which helps you in managing the life cycle, right? It helps you to, otherwise, you might have read about all those MCP horror stories. So Docker is trying to build a kind of tools which are open source in nature. At the same time, it helps you to get rid of this prompt injection and the tools poisoning and all of this thing, right? So what we learned till now is, in order to build an agentic AI application, I need three things: models, tools, and the code. And if we're able to stitch them together in a very easy way with security in mind, I think that would be a more successful agentic app or any of the agents application which you are building. Now let's jump into each of these category and try to see like how you can use today Docker desktop as well as the Docker offering, which can help you in building a secure agentic application. Let's talk about the models now. As you have known, there are close to around 2 million models on Hugging Face. It's more like a garden of these models, which you see every now and then. You have been hearing about these models coming up. And what are these models? These are just a snapshot of data. Pick up Llama 3.2. The knowledge cutoff date is last year, right? So which means that today, if I want to ask something to Llama 3.2, it might not know about it because it doesn't have context to it. It doesn't have the MCP tools attached to it, right? At the same time, when you talk about language models, right, it comes in three different variants. One is small language model, medium, and large. And now, when I created this slide, it was more like the max was 70 billion. Now it is like more than 200 billion, right? Now, the easiest way to understand this model is more like a kind of a very simple calculator, which I would consider as a small language model, 1 to 3 billion parameters. When you pick up the medium model, it's more like 7 to 15 billion parameters. And you have a large language model, which goes from 70 to 200 plus billion parameters, right? And this is, again, you can think of it as like a high-end MacBook, right? Now, if you look at the models which fall under these categories, you can see the 5.3 Gemma, 2B, Tiny Llama, and all of this thing. In large language model, we have a GPT-5, Gemini 2.5. We recently have even the Claude 4.5, right? So Mistral, all of these falls under this particular model. Now, I want to highlight one important thing here, and that is the reason why when we are talking about the multi-LLM architecture in agentic application is if you are using a single model, it's basically a trap. The reason being, if you have a Claude or GPT handling all of this thing, then you can expect that it might hallucinate at one point of time, or it might not give you a kind of result which you expect out of it. Think of it like if I am using Claude for a music generation. Let me tell you my experience. It's quite bad. The reason being, it is built for more like a reasoning, right? Not for all those, the music generation. It could be good for the code generation, but it is not good at the image generation, right? I would consider GPT-5 more like a, very good in image generation, kind of a video synthesis, translation. So if you are using one model to accomplish your task, you might not be getting a good performance out of it. It misses the domain specific capabilities, the vendor lock-in, the higher cost. All of this thing comes with a single model trap. So just the slide was more like for the informatory point of view. So how do I test all these models? And that's why we bring up a kind of Docker model runner, which can help you in trying out different models accordingly as per your requisite. So the model runner, compared to the traditional GenAI development, now you might be using a model on your IoT devices or any of the Linux machine, and most of the time what you do, you juggle in between how to configure it, run it inside a container. There are third-party tools which you can even use it, but you have to spend so much time. With model runner, what happens here, your model run on the host machine, which means that now your model have because of the component called as a llamas.cpp, you get access to your underlying GPUs. So which means that it is fast. You don't really have to worry about running this model runner on inside a container. On the Windows, if with the NVIDIA GPU, we do have a support for that. If you are running a Linux machine, still you can run this model runner inside a Docker container. So we give you support for all the, the three different platforms, Mac, Windows, where you run it on the host machine, and on the Linux machine, you can still run it on your inside a container. Now, how to run it? Like you need to go ahead, and we support both a kind of a UI as well as a CLI. So you just type Docker model and you can see the help page. It helps you to pull the model from registries as well as the Hugging Face. You can run model locally with your GPU acceleration. You can integrate model into the development platform and test all those GenAI based application, right? Now, what I have done here is I have included a kind of a tutorial for you guys to just go ahead and try out this model. So if I really have to jump back, let me show you how does it look like. So if you go back to our tutorial, there is a kind of, one of the lab which shows you how to run model runner with Compose. So we support model runner as the first model as a first class citizen under the Docker Compose. You can still go ahead and use it. So we'll see later point of time. But at this point of time, as I said, right, you can always use as a CLI as well as a GUI. To pull the model, all you need to do is Docker model pull, specify the AI as a namespace every time you pull the model, and then the model name. So how do you manage this AI model? Now you might be downloading or bringing up some kind of an application which use the API endpoints. Does model runner support it? Yes, it does. So if you are using a CLI, you can always, if you are running a GenAI application and you are running it from within the container, so you need to use model runner docker.internal, right? If from the host, you can still use local host and then provide the TCP host, which we specify in the beginning of the tutorial, like 12434. This is a port. You can always go back and change the port, but this is how a simple CLI look like. Now, say you want to use in terms of the OpenAI. Say if you are configuring an open web UI and you want to specify there, so we can still use the OpenAI endpoint. So how does it look like? To list the model, you can use /engine llama cpp v1 model. Okay. For retrieving the model, you can use the namespace. For listing the chat completion, you can say chat and completion provided with the llama cpp, and you can also do a create embeddings and provide it. So you can specify this path on open web UI and still you can do it. Interestingly, you can also use model runner as part of your GitHub workflows, because now the model runner can also be run inside a container, which means that you just have to go ahead and specify this workflow where it install the model runner, test this installation, run and pull and run the model, interact with the model with the APIs, and then delete the model. Okay, so you can visit this link where it shows you how to run it. This is a kind of a snapshot of how it looked like. Now, as I said, right, in one of the demo which we are going to see how the model runner integration with Compose works, right? Because when we talk about the Agentic Compose, right, it is just like a one single command, Docker Compose up, and your whole Agentic AI infrastructure comes up, right? One thing to remember is that if you want to specify model, we do have a capability of specifying model as a first class citizen. But there is one important thing to note. Whatever you are going to run it is not going to run as a container, but it is going to run it on the host machine, even though you have specified in the compose file. Now, this is a very basic example. You have a backend called chat app, which is dependent on the models called LLM. And I'm specifying the model as a first class citizen. And I'm specifying the model, small LM2. So now what happened that when I bring up this particular application, there will be only one service which will run called as the chat app. But my model is going to run on the host machine. Okay. This is really important because as we build an Agentic Compose, we are going to specify this model, and you can expect that it shouldn't be the case like you've been searching for those containers. It doesn't run as a container because at the end of the day, there is a component called as a llama cpp which load this model into into your RAM, and that is the reason why it is able to access your GPU. Now, to show you a quick demo here, because before we jump into the Agentic Compose, we need to understand all this concept. So I'm going to show you a quick demo here. So let me click on it. And this is what we are going to follow here. Okay. So let me see if it works this time. So what I'm going to do here is, let me see if I can open a new window altogether. So let me go back to my Docker desktop, remove this, right? So I'm just removing it, the entire Labspace, and show you from the beginning here, ensuring that I don't have all those containers up and running. There are a couple of them which are there. I'm just going to, let me see if they're already here. I'm going to delete them, just cleaning up my system as well as cleaning up all these volumes. So before you start, I would suggest you that to clean up all the system, especially with the volumes and all of this stuff. And we will start from the scratch. Okay, so I'm going to the lab space here, add a lab space. I'm going to name it as DevDuck and specify this as Docker samples. Labspace DevDuck. So this has a compose file. This is a published compose file. Again, as I said, right, you can always go ahead and contribute these lab spaces. It is an open source tool, so feel free to go ahead and use it. So you can see here that most of this configuration, there is already a container of Labspace configurator which is running. Let me see if it can help again. Just ensuring that I should be able to run those commands. So my Labspace is up. Let me quickly see if things are working fine. I have a model runner here, and I can see here that, okay, now this time it works. So what we are trying to build is a kind of a chatbot, okay, which just use your backend as well as it will just use the models, okay. So right now I have cloned it. By the way, I am at the third lab, which uses model runner with Compose. Now, meanwhile, I am going to show you how does it look like. Once it comes up, I will show you, I will walk through the code. Okay, so now what we are going to do here is I will be using Llama 3.2 for this particular lab. The reason being, it is just like close to around, I would say 1.5 GB in size. It's lightweight. Okay. Now, if you look at this particular stuff, I have a Docker Compose file. And right now, when your Docker Compose get kind of a lengthy, what you need to do is you can use Docker include to specify all of those Compose file. I'm going to pick up Python here, or I can even pick up Go. So this is a particular project where I have the chatbot, which I have, which my team has built in terms of Go, Node, Python, and Rust. I can get into the Go, specify Docker Compose file here, right? And if you see here, what we have done, we have specified the backend as well as the model here. So I'm using Llama 3.2. Before I run this particular model, I need to ensure that this model is already downloaded on my machine. So if I go back here, go to the models, I have already Llama 3.2, which is up and running, right? And it shows you about the quantization, the parameter, the size, and all of the stuff, right? Okay, so what I'm going to do now, I will go back here, and one of the important thing here is I need to pass the environmental variables here, specifying which model to choose, what is the base URL. And as I said, right, whenever you are trying to access the model runner within a container, you need to specify model runner docker.internal. So that is the reason why I have specified it here. If it is in the host, then we use the local host. So just be aware of the fact that we will require this. Most of the time, what I have seen, the query is more like I'm not able to reach, or I'm not able to integrate the model into my backend system. I think that problem should be solved. So I just say Docker Compose up, and my application should be up on port 8080. So you can see a chat window here, and I should be able to get into a chatbot and start chatting with it. So right now I am using everything locally. I'm not using any cloud API, no GPT, nothing. Okay. Now I can say, write a poem on Docker and AI and try to send it. Okay. And now whenever you run this command, at the same time, you will see that my GPU, if I go to the activity monitor here, right, I can open up the activity monitor to show you quickly how it is being consumed. So I have an M1 Pro machine. I can quickly get into the window, the GPU history, and right now it is idle, right? The moment I run any of the prompt, right? Say, write, okay, so let me go ahead and pick up one of them from the top, or hang on, let me see if I am back here. Okay, let me open it again. Look like it got closed. So if I how to use Gen AI, right? So the moment I do how to use Gen AI, you will see a spike which indicates that your GPU has been is being used here, right? So which means that when you run a model runner, we are not going through all this configuration of, say, if I'm using an NVIDIA GPU, then most of the time before model runner, I need to go ahead and configure the GPU. I need to ensure that the toolkit, right? Your toolkits, NVIDIA toolkits are there installed, right? But now with on my Mac M1 Pro, I have a GPUs and I am able to go ahead and use the model runner. And model runner, what it does, it loads the Llama CPP. Llama CPP helps you to load these models into your memory and then it runs it. This is just for awareness, like what we are trying to do here. Okay. So going back here, so you saw that how easy it was to use the backend along with the model as a first class citizen, right? Now this looks good. And this was all about the demo which I wanted to show how the model runner runs with Compose. Now let's go ahead and try to look at the another component which I'm going to talk about is the tools. And when we say tools, it basically I'm referring to all those MCP tools, right? Usually we take MCP server as more like a logical component, and the tools are the one. Even if you go to the cloud config, you will see that there are tools which are listed, not the MCP servers, right? So what is MCP? MCP is a kind of an open source framework which helps you to provide a context to your LLM, which means that now LLM won't hallucinate. The reason being it has always an accessibility to the real-time tools. And that is where you have an MCP client, MCP server connected to your all those, the database. As I said, right, there are more than around 8,000 plus MCP server today. And it provides you with the tools, prompts, resources, and all of this thing, right? We have been talking about MCP for a long time now. Now, when we look at the MCP as a whole, right, we have a server, we have a client, we have number of this MCP. There are certain difficulties and challenges which you go through when you start using this MCP server. The first one is discovery. As I said, right, now, if you look at this particular repo, it has 71,000 GitHub stars and close to around 8,000 plus MCP server. If you go ahead and pick up any of the GitHub MCP server, you will see 10 different variants, right? Whether it is coming from the official, unofficial, the more the tools the MCP provides, people are more attracted towards that, right? But at the same time, when you are, this looks good in terms of hobby, but at the same time, when you are in the enterprise business, right, you need to consider all the security parameter from where you are downloading the MCP. So discovery and distribution has always been a difficult task when you start, finding out the MCP servers, right? And you can see here that we have a repo called as an awesome MCP server. And as you scroll down, you get tired. The reason being there are so many MCP server. Pick up any of the web application or databases or any of the server implementation. Even I've seen like few of the governments have started building the MCP server. I don't know whether we should trust that, but at the same time, there are a bunch of these MCP server which are lying down in the internet. And so discovery is the most difficult thing here. The second one is the installation. As I said, right, when you install an MCP server, say you have a 5 different MCP server installed on your local machine, it might consume a 5 different version of Python. And again, we are stuck at the same problem where you have a dependency hell. You need to ensure that all those MCP server built in Node.js or Python should come up well. The second one is more like, look at this, like the npx to be installed on your local machine. So this is a very simple cloud config file, which you see in the form of a kind of, the JSON format, where example of a GitHub. So what you do here is more like you pass the command like an npx, right, which ensure that you need to have a right version of Node.js installed on your machine. It might or might not work. At the same time, you are picking up anyway from the server GitHub, but it could be, your own MCP server, right? And when you configure this MCP server with the client, it is more like a 101 connection. So if I have 100 of MCP server running on my machine, which you can expect that we have 100 server to client and client to server, all those connections, right? And as I said, right, you can have a different version of Node.js running, different version of Python you are running. So these MCP client does one-to-one communication with them. And that's where the whole management system itself gets so complicated, right? So discovery, we talked about discovery, we talked about installing. And the third one is a credential, right? That which is really important at this point of time. Look at this particular GitHub config, which the MCP config which you add to the cloud. You can see here that whenever you pass a GitHub personal access token, we are passing it in terms of a very plain token, right? And if someone hacks into your machine, definitely this is something which is a text file, which is just lying on your hard disk, right? So the concept of secrets and all of this thing is something which you might not be able to use it unless and until you have any of the capabilities. So we do have that kind of a capability which can help you to implement those secrets. And there are multiple other challenges, like each client launches his own server, lot of container and connection, many containers need configuration and all of this thing. So now, how do we use this tool, especially the MCP server, safely? How do we not increase our risk? And how Docker is trying to solve this problem? So we came up with a kind of a feature called as Docker MCP catalog. Right now, we have close to around 220 plus. This slide has to be updated. These are containerized MCP server, which is running on your machine. It includes Stripe, GitHub. I think we have already seen that it is all in the Docker Hub. We have an MCP toolkit, which basically helps you to configure and package to securely connect all this MCP server to your desktop agentic apps, right? You can see the client's catalog servers. I can go to the catalog and look at all those MCP server. So as I said, right, you can add your MCP server, search in the catalog. So we have both the CLI version as well as the GUI. You can use both of them. So we have a Docker MCP command also. Now with Docker MCP toolkit, the beauty is that instead of having 101 client to server connection, now we have a single Docker runtime. And that's the beauty, because when you have a single runtime, it's very easy to manage those, right? And you can see here that all the API tokens and credentials, still we can use a secure credential injection for this. So MCP toolkit is basically what it does. It launches your MCP server with a very minimal effort, credential storage and secure injection into your containers, which means that we are not talking about a plain text environmental variable or personal access token. Everything runs the secrets, right? And the single connection endpoint. And I will talk about one of the open source project which we have called as an MCP gateway, which is really, again, a very powerful feature. But the idea of the MCP toolkit is help you with the security, because now when you see there are multiple 101 connection in between server and client, there are chances that you need to manage all those credentials, or you need to even have a third party tool to manage it. So with this, we support with standardization distribution, no more runtime, security at work. But how to manage this life cycle of containerized MCP servers? So think of it as like right now I'm running around 15 to 16 different MCP server. How do I manage that? And that's where your MCP gateway come into the picture. So what does MCP gateway does? It's just like a very kind of when you run a agentic application, and when the agents wants to talk to the MCP tools, so MCP gateway sits in between them to help you in containerizing this MCP server safely, securely, directly into your application stack. As I said, right, we can run gateway on the host machine as well as we can run it as a Docker container. So a typical agentic application, which was looking something like this, now looks something like this, okay, with the MCP gateway. So initially we had a kind of a user input agent application with the memory as well as the LLM in place. And now if the agent application wants to talk to directly to the MCP server, as I said, right, we have a component called as the MCP gateway. Now it has to go through the gateway, and this is a component which helps you to manage the life cycle of MCP server. We have a concept called as MCP interceptor, where we can have just like a firewall kind of a stuff. Like if any request comes, I can check whether this request is legit or not, right? So with this, now you can see here, we are not just talking about the agentic AI application. We are talking about the secure AI agent application here with LLM in one place, which helps you with the reasoning. We have agent application where you are building the agents using any of your preferred programming language. We have an MCP server sitting there, okay? And before the agent reaches to any of these particular MCP tools, now we can put an interceptor in between. If we want, we can have MCP gateway, we can monitor, right? At least we'll get to know what kind of an information is flowing from the agent to the tools. So a single gateway to all tools, authentication, secrets, and config management. So today, if you see MCP gateway is like an open source tool. If you go to github.com/docker/MCP gateway, you will see all sort of those features, how it can be run as a container, how it can be run on the host machine. You can do all those filtering and rate limiting stuff. So how does it look like? So when you want to run, if you want to run MCP gateway as a container, so this is a command. You can run a Docker run command, specify as an MCP gateway. If you want to use the catalog or the MCP toolkit, I can just specify the catalog. All of my MCP catalog servers is basically stored in Docker MCP YAML under the MCP catalog directory. So I have both the options here. If I want to run it on the cloud, I can still use an MCP gateway and run it on any of the machine. If I want to use, say, if I want to leverage the MCP toolkit of my Docker desktop, I can still use this one. Okay, so which means that now you can run Docker and you can specify your own port here and use API socket if I really want to go ahead and use the MCP toolkit. So in this particular example, what is happening? You are orchestrating and managing the MCP server securely across your dev and prod. It handles your API keys, credential, right? So you can use Docker MCP set command to go ahead and set those credential. And since we will be more talking about the Compose side, so we will look at how this MCP gateway can be run as part of the Compose services. And again, as you are running in a container, it's always safe, right? And you can pass all those interceptors, you can pass all those, the catalog which you have added, and then especially you can even pass all those servers with just like an -n server. You can pass all those servers. Okay. Now, calling MCP gateway from Python client. This is a very simple example where, say, if I have a client and it depends upon the gateway, and in the gateway means I'm running as kind of an MCP gateway as a container here. All I need to do is -n servers, DuckDuckGo, and this MCP server can be consumed, right? So which means that you don't really have to go through all those configuration files. Like with this simple Docker Compose file where I have one service running as a client, the other service running as a gateway, I can always go ahead and bring up my agentic application. So in the coding AI agent which we are going to build, we are going to leverage MCP gateway, we are going to leverage the model runner, the Cerebras as a cloud API, and then stitch them together to bring up your agentic application. So one of the thing which I want to mention about the MCP gateway, because as you know, like Docker is expecting you to come up with some kind of a new idea as a project in terms of MCP gateway. One last feature which I want to mention about the MCP gateway is an interceptors, right? There are three different deployment models. We have shell, container, and HTTP. And shell is more for the quick policies. Container is more like a more complex stuff, and then HTTP more like the enterprise integration, right? And again, it comes with their own complexity as well as a security. Say if you want to use an interceptor here, okay, in terms of shell script, say if you have certain shell script which you want to before the agentic application talks to your tools, if you want to pass on few of the scripts and check whether it is legit or not, so you can use even the shell script here. It is perfect for security policies which you want to enforce. There's a tool calls which are passed to the JSON. So all you need to do is -f interceptor, say before and exec this particular script. So before the control or the agentic application talks to your MCP tool, it is going to go ahead and use this particular shell script to validate it. And let me tell you, like in most of the horror stories which I wrote, like this was something which was really useful in order to fix it. Because if you look at those horror stories, are more like in one way they are tools which are used by the developers, they are getting infected, right? So in most of the blogs, if you see, these are really helpful components. If you get into those horror stories, you will see, like I have talked more on the interceptor side. If you want to implement it in terms of, say, if you are deploying a Docker Compose file and running the MCP gateway as a service, then you can just pass interceptor and run it as a Docker container also. So it is perfect for the complex analysis. I will show you a few of the examples where you can find all those Docker MCP examples. And then we have an HTTP service acceptor, which is perfect for your enterprise policies. So let me go ahead and show you all these examples. So if you go to github.com/docker/mcp gateway, right? Again, as I said, right, open source project, right? You can go to the examples here, and here you will see a couple of gateway setup. Say if you want to run MCP gateway in a container, this is how it is going to look like. Maybe maximize it. If I want to run a simplest compose file, just one MCP server, right? If you want to have a Python client connecting to the MCP gateway, you can pick up, and all of these folders are here. What I was talking more on the interceptor side, you can see here the interceptor, and I will quickly show you an example here. So I have one service called as a client, which is again depend on the gateway. And in the gateway, I have specified servers like the DuckDuckGo. You can specify the transport is streaming, and then I can pass all those interceptor here, before and after. What will happen when your agent application wants to talk to your MCP toolkit? Okay, let's validate this, whether it is legit or not. So that is the reason why we named this workshop as is not just like a coding, AI coding agent. We are naming it as secure. The reason being we have an MCP gateway and all its capabilities, right? At the same time, one of the beauty of the MCP gateway is you can even run it as Docker in Docker, okay? And I can show you the compose YAML file here. So if you really want to go ahead and run it inside, the Docker, so you can still do that. I would suggest you to go to the MCP gateway and look at all those, we have a Postgres, we have a remote MCP, the secrets, right? All of these examples, I'm sure like you are going to get a lot of good ideas around it. And if you have any of the issues which you are facing, anyway, we are available on the Discord as well as the YouTube chat window. We can definitely help you on that. Now, moving ahead, I am going to quickly talk about, as I said, right, we covered models, we covered tools. Now let's talk about the code, because this is something which is required, right? You need to build some kind of an agent application, whether I should use this programming language or not. So how does it work? Basically, we are just talking about the Agentic Compose, right? We are bringing together the models, services, and the MCP gateway. Models, we are picking up any of our preferred models, but again, you need to choose the right model for the right thing. In terms of tools, we are specifying in terms of MCP gateway, we are passing all those MCP server, and then finally we have code where we are writing, say if you want to write on Python or Node.js, it's your choice, you can go ahead. And then these services are going to consume your models, right? Whether it is a cloud API, like an OpenAI, Open API or AIN. So those kind of stuff which you can still do it, right? OpenAI model, you can use it. Now to show you, before we jump into a kind of how, now I'm going to walk through the code, like what we have implemented. But let me tell you that we have a repo called as Compose for Agents, where we have a couple of examples showing as a different framework. So right now we are just using an ADK here for our example. But say if you want to use CryoAI or LangGraph or Vercel, right, you can still use it, right? And for this, I want to highlight one of the repo here. If you go to https://github.com/docker compose for agents, right? You will see here that there are a couple of examples here, list of the demos, A2A, Agno, Vercel, CryoAI, ADK, LangGraph, and I would suggest you that go through each of these projects. Definitely you will get a lot of ideas around it, right? And this repo is already, it is close to around 600 plus stars now. But this is something which helps you to build an agentic compose. Like it helps you to build an agentic application using agentic compose, right? And if you look at, say, if I pick up the Creo AI here, it goes through all those, it shows you, there are both the ways. Either if you want to run in a cloud, we have a Docker offload, which you can use it to deploy it on the cloud. If you want to do it on local system using the model runner, still you can do it. You will see a variants of compose file here. The first compose file is an OpenAI. If I want to use an OpenAI, how does it look like, right? If you want to run it locally on the offload. So It is very comprehensive. I would suggest you to get into this particular repo to understand how these all the frameworks can be used. And as I said, right, the main intention is MCP gateway, but feel free to use any of these frameworks for the hackathon activity. Now, we have come to the point where now we have models ready. We have the required models which we have already downloaded. We already have an MCP tools which we have already finalized. Okay, let's use context 7 as well as your Node.js sandbox. And we now know how to stitch the code right. Now, what we have done as a Docker team, we built a kind of a coding agent for you, just to give you an idea about how these particular stuff stitch together to bring up an agentic AI application. And this is how the whole architecture look like. Starting from a user interface, we have a DevDuck orchestrator, which is a very intelligent orchestrator. Think of it as like a project manager. Okay. And DevDuck orchestrator manages two of the agents. One is a local agent and the Cerebras agent. Okay. Now for this project, we will require a Cerebras AI API key. Okay. Because we need to talk to the cloud API. And then we have a local agent where it is going to consume a local model runner. So right now, as I said, Giant Nano as well as the Lucy, these are the two models which we are going to consume. And let me tell you something that Cerebras, we are going to, for this particular use case, what we have done, Cerebras has access to those MCP tools, and that will go through the MCP gateway. So it will all start from the user interface, goes back to the intelligent orchestrator. There are two agents. Now, why we are using two agents here? Okay, we are using a local agent. The reason being, again, when you look at the local agent, again, it does the reasoning pretty well, but it can't do all those complex application. It won't handle. It should have access to those MCP tools, right? So in order to do that, we picked up a Cerebras agent, which is more capable. It has support for those MCP tools, and then it goes to the MCP. It has access to, so agent has access to all these tools through your MCP gateway. Okay. Now there are two MCP servers, Context 7 and Nodes Sandbox. We are going to ask, so for, if you look at all the prompts which we are going to pass, we will ask some first the simple operations. For that, it will use a local agent and talk to, and then when we are doing a complex operation, right, that is where your Cerebras come into the picture, and Cerebras is going to use the Context 7 for get the real-time access to the documentation, as well as the Node Sandbox to execute or run a container, okay, in a sandbox environment. So just to highlight where these codes sits, so let me go back to my DevDuck multi-agent. So we are directly jumping into the DevDuck multi-agent, which is lab 6. Okay, so let me open it here. I will close this window. So let me go back to the DevDuck multi-agent here, open new window here, and ensuring that I already have closed it. Okay, so this looks good. Okay, so what I have done here, I have whatever we discuss about how these compose and serve as a foundation of the entire multi-agent system. I have tried to capture all these points. This will be really helpful. What are the roles of each of these agents? A DevDuck main agent, which is a Giant Nano. It is basically more like a project manager. We have a local agent, which is very good worker, and it does a general development task. For all those advanced computation tasks, right, that is where we are bringing a kind of a Cerebras, and Cerebras is going to be Llama 4 Scout, right? This is hosted, and again, Cerebras, the beauty of Cerebras is that it comes with their own the high configuration GPUs environment, where I can do a complex operation. I can run those prompts. So this is how the repo look like. And just to highlight here, I'm going to open a new window here and then run this command. So once I clone it, it basically opens up a Docker samples Cerebras demo. So let me show you this particular project here. Again, it is an open source project, and we'll walk through all the code right now. Okay. So if you go to Docker samples, Docker Cerebras demo, you are going to see all those required files. I have docker compose.yaml, which I'm going to jump first. So we have a couple of services here. Okay, let me open it directly here itself. Why should we go there? So I have a compose.yaml file here. Now let's look at what this compose file holds, right? So start with a kind of a DevDuck agent, as you know, like we named it as a coding agent. So there is a service called as a DevDuck agent, and what it does, it basically picks up the Docker file from an agent's directory. There is an environmental variable where I need to pass the Cerebras API key. Okay. Then we have models. Two of the models, the local agent, which we have specified here. There are ports, the MCP gateway endpoint, right? And then if you look at the MCP, when we specify the MCP gateway endpoint, we also specify the instruction. Okay, you are a DevDuck, or your answer must start with a DevDuck speaking. So when we start interacting with the DevDuck, you will see the name of the agent appearing there. Okay, so these are the instruction which goes as you might know, like instructions, description, and name is something which you need to add for all those agents. I'm also passing the base URL. So we need to download a kind of an API key, ensuring that you already have an API key for this. So I will try to see, like I will create a kind of a demo API key and just we'll try to use it. And then we have the second service, which is called as an MCP gateway. So what this MCP gateway does, as I stated, we are using two MCP servers here, Context 7 and Node Code Sandbox. When we are doing a testing, we are going to use Node.js Sandbox for Context 7 to get a real-time information about some kind of a documentation. And at the end, if you see here, I'm specifying all of these models which are going to consume. So I'm not consuming Llama 3 for this particular example. I'm just going to consume the Mistral, the Jan Nano and the Lucy, right? And this is how my Docker Compose would look like. Now let's spend some time looking into the agents and looking into the main.py. So as you know, right, we are using an ADK framework. So that is the reason. And this framework is used to create an agents, right? So that is what you require. We have a fast API here. Now, if you look at the ADK, right, by default, it uses a Gemini model, right? So if I really want to use outside it, then I need to have some kind of a wrapper, and that is why your light LLM come into the picture. And rest of them are more like, self-explanatory. So this is important. The first one is the fast API, which I'm using, for my application. ADK is using for creating those agents. Now, if you go to the DevDuck and to the sub agents, and then in the sub agent, I've specified let me see if it is visible. I have a Cerberus and the local agent, and all this are specified in the agent.py. So if you see here, the local agent is going to use the local model, whereas the Cerebras, under that, it has, as a Cerebras has access to the tools. So I have a tools.py file. So if you look at the agent.py, it is like the whole light LLM wrapper, which we are using it here for the tools. What we are going to use it more like, how it is going to consume those MCP tools, right? How the MCP gateway and all of this stuff which we can use it. So all those MCP gateway endpoint where we have specified it. Now, the first thing we need to do in order to run this is pass on the Cerberus API key. So what I need to do is go to the Cerberus here, and there is an API key here. I'm going to copy this API just for this particular demo. I'm going to remove it once this workshop is over. But let me show you how I'm going to let us go ahead and pass this particular API key directly onto your machine. Let me do this. And again, one of the thing what we can do here is I can go back and see like what are the other entries which we require here. We have an MCP gateway. And for this, what I'm going to do, I'm going to use the Llama 4 Scout as I promised in the initial. So with this, I want to pick up any one of the model. Now to copy paste it, you need to have a Command Shift and V, and that will copy paste here. And the Cerberus API key, which I'm going to pick up, I'm going to paste it here. So once I'm done, so let me see if I picked up the right one. I'm just going to go ahead and save this. Okay, hopefully it should save. I'm going to close this one. So all you need is a Cerebras API key to be added. Again, it is a dummy key just to ensure that I delete it once this workshop is over. So, so the first thing I need to do is copy this env file to env, and I should be able to see this, right? And what I need to do is docker compose up and hyphen build. Okay. Now what it's going to do, it is going to build up the whole tech stack. It is going to use being, the models will come up. Then we have the unit going to use this particular model, the MCP gateway as a service. And soon, if I go here and to the containers, I can see here my Docker Cerebras comes up. It is running on port 8000, and that is where your agent development kit comes into the picture. Now, to show you a quick demo, what I'm going to do here is we'll go through the sequence of, the instruction. So think of it as like, let me start with, say, who are you? Okay, because we have a multi-agent environment. So I'm just going to go ahead and say, who are you? So that I will get to know which agent is active right now. And as I said, right, we have a project manager in place, which is called as a DevDuck speaking. Okay, I'm a DevDuck, your main development assistant, because we are talking about the project development. So one of the things which I'm going to do here is, enable token. So you can see here that the whole flow, how it look like. But again, we can always, look at all those responses. Okay, fine. The next one is just to verify that all my agents are, active. So I can say, connect me to local agent. So when I say connect me to the local agent, I'm expecting like, the transfer to the local agent works. So just to verify that all my agents are up and running and I am able to move from one agent to another. Now, as I was talking about a single LLM trap, right? One single LLM doing all this thing right now, if you can see here, I have a multiple agents coming to the picture, and these agents are nothing but they are consuming the separate LLMs, right? So you can now see here that local agent is speaking. I'm a local agent and Node.js programming expert. So I got to know about, okay, this is a Node.js expert. I want to talk to Cerebras. Let me see if it works. Okay, so now we are switching from one agent to another. We started with the local agent and now the Cerebras, right? Now let me pick up a kind of a random info, because since we are talking to the Cerebras, I'm going to say, okay, search documentation for express routing. Okay. Now, as I said, right, Cerebras has access to the MCP tools, which means that it has access to those context 7 MCP server, and this context 7 is going to fetch me all the latest information about the express routing. So let's go ahead and try this. Now, as we were talking to the Cerebras, right, as you know, Zach, we are talking to the Cerebras, the response is from the Cerebras itself, right? Okay. It says like, okay, try to search documentation. Okay, let me see. Okay, what can you do for me? Let me see. Okay, as a specialized agent for advanced computation tasks and complex problem solving, I can assist you following. Okay, can you help me with complex algorithm for setting up, a to-do list application enabled with AI on AWS cloud. So some kind of, I'm throwing on a kind of a random thoughts here. But if you look at this, it is going and trying to recommend me with something, right? Okay. The whole idea is getting all the information. When you say AWS cloud, there are multiple services on AWS cloud, right? If I'm talking about any of the to-do list application, there are multiple components in place, right? You have front end, you have back end, and based on that, Cerebras is going to speak. Now, one of the other thing which I want to try it here, because we tried the context 7, right? So more like, okay, whether you get all this information or not. One of the other thing which I'm going to try is, okay, can you create a function that adds toNumber and test it in the sandbox environment, just to test whether the Node.js sandbox environment comes up or not. And if you see here, what is happening here is it is trying to, set up a container. So you can see here, as all like developed this particular a kind of a solution. So I think is namespace at the sandbox. So right now, if you can see here, I have a container which is up and running, and all those, it is trying to do the testing inside a Docker container, right? So which means that the execution phase is happening here. Okay, so you can see here that the function add and none has been created and tested in the sandbox environment, which means that now the agents are basically talking to the MCP tools, which is the Node.js sandbox, and executing a container and running it on your local system and testing it, right? So you can go ahead and try out all those complex stuff. So let me see if I can make this particular stuff. So again, as this was something which was failing last time, let me see if it works this time. Search for the documentation for express routing, and you can see this time there's no, okay, I think it should be some kind of express JS routing or something like that, but it was able to fetch that. Okay, although it's not directly related to the routing, it gives you the information about the latest about the express.js, give you some kind of an example here. So what we have seen here is more like, we went through each one of these kind of, the prompts which we saw, like how each of these agents are coming to the picture. So primarily what we saw here is more like initially the user request goes to your fast API, to the Google ADK orchestrator, to the local agent, and through the light LLM call, it is going to the Docker model runner. And the model flow is more like for the Cerebras agent is more going to the cloud API. But at the same time, when how these agents connect to the MCP tools, this was through two of the files, tools.py and agents.py, where we have an MCP gateway connection as well as the Cerebras agents, right? So with this, you were able to try to see, like, this is a very simple example of, say, create an express API endpoint for user authentication with JWT. This could be like a the right prompt to use, and this is where your DevDuck orchestrator come into the picture. And under the Cerebras agent, we have two different tools now that gets triggered, and that is where your whole AI, the secure AI coding assistant can be implemented. Now, I think with this, I am towards the end of this particular workshop. There are a couple of the references which I have tried to put it in the slide. Maybe I can share it if you guys want. So if you really want to, so there is one blog which was written by Oleg on the Cerebras Docker Compose Secure AI Coding Agent. You can also visit Docker DevDuck virtual.app. For the MCP gateway, you can go to the GitHub repo, and then there are a couple of docs pages which you can go through it. So yeah, that's all I have today. Is there any questions which I need to go through?
Yeah, I guess you have covered a lot. Aditya, and I personally would like to give you a shout out on the slides. I saw there are more than 100 pages, so this is insane. But yeah, even I like the section wherein you demonstrated using a calculator the difference between small and all the language models. But yeah, that's just for the beginner folks. The session was even more deeper. And thank you so much for covering everything in depth. I guess pretty much most of the questions were given answered by Oleg in the chat.
Okay.
I guess let me just quickly go through all the questions once. Just a quick skim through. Let's see if anything was missed in the some important questions, if they were missed or not. I guess we did already cover the prerequisites in the session, so you can just go back to the session and just have a look. Discord link was also given. Would you like to take this up, Oleg, Ajit? Will our PC's compute be enough to sustain?
I sort of answered in chat, but so the thing is very simple, right? Yes, for running models locally, you will need some compute. And for running them efficiently, you will likely need some GPU resource, which your laptop normally will have. So if you're building local workflows or local agents you can pick a model that will fit your machine. I've run some very small, and albeit they are kind of on a sort of weaker and more useless side of models, but I successfully run them in the GitHub Action worker, which is a very sort of low power environment, right? Like there is like one CPU and I think maybe 16 gigs of RAM, but like no GPU. And you can run models there. So you can run models locally. Depending on the size and the hardware, you can run more sophisticated models. One of the particular aspects of that is that you can build completely private environments, which are very, very good, right? If you want to process some data that you don't want to share with any third parties, this is great. If you want to build encapsulated solutions where you don't want your customers to like start figuring out whether they trust with their data to like some cloud provider, you can build this, but you have local compute requirements. And likely those local models will be somewhat slow right now. I have a very powerful M4 Pro maxed out Mac. And still, when I run models that are sort of at the edge of what I currently can run, they are slow, especially if I want larger outputs. If you want something simple, then probably it can be fairly fast if it doesn't need to generate loads of text. However, if you want to have a solution that actually works with large data sets or outputs quite a bit of tokens, it's very likely you will need to rely on a cloud provider for the managed inference endpoint for you. For this hackathon, definitely check out Cerebras. There's a link in the description. Go there, get your API key. They run the world's fastest inference for a number of open source models that are available. I don't actually know whether you run any non-open source models, but you can get Qwen, which in my book are sort of state-of-the-art open source models right now, topping all the charts for both sophistication, intelligence, tool calling, and so on. You can get Qwen Coder, which is like roughly half a trillion parameters, and you can run it at like 2,000 tokens per second, which is absolutely unbelievable. So if you come up with any ideas for agents where performance of inference is essential, definitely check out and build it with Cerebras. For this, you can supplement it if you need with like some local models for maybe smaller data processing or some private things like, I don't know, summarizing some outputs. Or if you really do not have any sort of latency requirements. But for many use cases, you need that speed, and then Cerebras is definitely a friend.
Moving to the next question, can we get a recording of this session? Yep, this will be recorded everywhere over X, LinkedIn, and YouTube, so you can find it after the session ends, or maybe now as well. There were a few questions I'm just trying to find. So if you're finding any errors while installing anything, maybe Discord with the right place. You can post it there, and then maybe Oleg or the team can help you, get to the next step.
Just in case, update everything. Switch it off and on, try again, and that's the recipe for solving a lot of issues.
Yeah. My question is that if it's expectable, if I want to use a Docker, yep. So see, if you use multiple tools, again, you'll get chance to be eligible for all the 3 tracks, right? So make sure you use most of the tools. But even if you are only using Docker, you'll be eligible for the Docker track. So make sure you use it to the best. I guess that was it. I guess, Oleg, you got a lot of shout outs for helping folks in the chat. So thank you for that.
Yeah, my pleasure.
Thanks, Oleg.
Yep, I guess
the chat.
Sorry, Ajit, can you come again? I missed it.
I just wanted to give a thanks, Oleg, for taking care of the chat window.
Yep.
Absolutely.
There is one more question, I guess. Which model can be used for embedding generations, if anyone would like to pick it up?
Oleg, do you want to take that?
Yeah, so like the embedding models are the ones that generate the embeddings, right? And they are usually marked with embedding. For example, if the AI namespace on Hub, you can get embedding Gemma, which would be very good if you are using, for example, other Gemma models from the Google's family. On Hugging Face directly, you can find a bunch more. I've heard, again, good results with embedding Quen. I think it comes at 0.6 billion parameters, which is very small, but fairly good for embedding. So if you're building anything with RAG for retrieval augmented generation, or if you just need to compute like some embedding vectors because you want to do that, then maybe Quen embedding is good. And then, of course, the normal one, I think you get like what, Arctic embedding, and then whichever you try. I'm not a professional in the embedding models. I'm sure they have their differences and they work differently and better and worse in different contexts. For my agents, usually they perform. I didn't actually performance measure them, right? But they all performed similarly well. So you can pick your favorite, which sort of should work well with your main inference LLM, and then sort of go with it. I'm sure that would be a point that you can optimize later, but also probably not going to be make it or break it for the hackathon. Very likely there will be other parts to optimize first, tweak your system prompts, build better reporting systems, figuring out observability, plugging in better tools, developing your own MCP servers. Like you can run your imagination wild. But yeah, there are some usually embedding tagged models.
Can you please?
Yeah,
Sorry,
and just
sorry.
to add, to add, like
Please.
if you go to the Docker Hub, right now you will see there are a few of the embedding models which you can use. At the same time, I would suggest, as Oleg said, right, pick up those models where you don't really have to scratch your head. Those models which are already been matured and these are available, so that you can focus more on the MCP gateway part rather than figuring out like which embedding model should fit into it. So even though there are few of the models available on Docker Hub, but I would suggest like pick up those matured models for your use case.
Can you please post the Discord link for the community? Musa can be found in the description, or you can just head over to Cerebras website. You can join the Discord from there as well. I guess we'll take one last question. Can you use GPU for free with these labs? Or like Ajit, if you would like to answer.
So definitely, again, it depends upon the infrastructure, right? So if you are using MacBook, so all the labs which I conducted right today is on an M1 Pro, which comes with the GPU. Say if you are on the Windows machine with NVIDIA GPU, so there is an option where you can just enable it and get started with it. And think of it as like if you are on a Linux machine, then in one way you need to do some kind of a configuration around it, because now you might be using some kind of an IoT devices with NVIDIA GPU. You need to configure with it, right? But for Mac and Windows, we already have a model runner which supports the GPU, so you should be able to go ahead and leverage that.
So just before we conclude, I see you are new here. So this workshop was for a hackathon named Future Stack Gen AI Hackathon. It's sponsored by Cerebras, Docker, Meta are the co-sponsors. So you can just check out the website. Link can be found in the description. And we'll be hacking for the complete week. So make sure you leverage all the tools and build something amazing to win amazing prizes such as $15,000 in cash prize. Also, I just wanted to mention that we'll be also having some mentoring sessions. So you can find Oleg on Thursday, if I'm not wrong, over Cerebras Discord, looking over the projects or giving some career guidance, and as well as some Meta folks would also join for the same. So again, thank you folks for joining. And thank you, Ajit, Oleg, for the session and for helping in the chat. And we'll see you tomorrow with another session. Yep. Thank you.
Thank you.
Bye. Good night.
Thank you.